All right. Hello, everybody. My name is Matt Ruby. I'd like to welcome you to More Practical React with MobX. I work for a company called Room and Board. We sell really fantastic American-made furniture. Please buy some. Today we're going to spend some time talking about state management. Now, this is not necessarily a React issue only. This is just kind of an overarching problem you're going to run into with just about any application you build. Let's look through a quick example. So this person object represents some state. This particular person object represents me. I think my age is 37. It might be 38. I can't remember. But my first name's Matt. My last name is Ruby. Age is around 37, and my full name is a combination of my first name, a space, and my last name. So in most applications, you've got to keep track of your state, right? So when this person changes, you'd want to know about it. How would you go about doing that today? Would you have maybe an event that, like a signal that lives on each individual person, that would fire when that particular person changes, right? If first, last, or age changes, you'd fire this event and whoever cares would listen to it, right? Maybe you could have setters for first name, last name, age, and anytime you call those set functions, it would trigger something to let somebody know that, hey, this has changed. You could have something where anybody who changes the person, when they're done changing the person, they could then fire an event saying, hey, go do this now that I've done my job. All those are just some different ways that you could keep track of this person changing. Typically, you'd probably do it at a fairly high level, right? You're not going to track first name, just first name changing all over the place, right? Just because some of your code over here is only making use of first name. Typically, you would do it at the person level. That's kind of what we're going to spend a little time talking about in the beginning of today. Let's talk about MobX. MobX is your simple, scalable option for state management. What's the deal with this thing? I've never seen it before. Whoops. The whole premise behind MobX is just do something to your state, and anywhere you make use of that state, MobX will make sure your application has respected those changes. And it does so in a very granular way. Why do I think you should be using MobX? MobX is very simple. The API, the core API of MobX is very, very small. It's also very, very well focused. So in this discussion, we're going to be going over MobX and React. However, I'm going to spend quite a bit of time on just going over MobX proper. MobX has nothing to do with React, just like React has nothing to do with MobX. There's a MobX React separate project that kind of helps bring the two together. So MobX is completely standalone. It's very, very fast. And there's many reasons why, but you'll see it. It really helps your performance. MobX is very unobtrusive. So you're able to work MobX into your existing applications with almost no impact. And I am going to show a demonstration of that a little bit later. One of the main premises of MobX is anything you can derive from your application state, you should. And you should be able to do so automatically. So if you kind of think of it on a high level, you've got some data, right? Well, without that data, what would your view be? Not much is the answer, right? So your view is just a derivation of your state data, right? It's just a display of your state. Just as if you were going to send that data off to the web server or some other endpoint, it's just a derivation. I like to kind of think of MobX in terms of spreadsheets. So in this example, you can see we have a first name, a last name, this full name. If I were to update the first name to Matthew, for example, I would expect the HEW to come in on that full name. But if I were to edit age from behind the scenes here, I wouldn't want any of this stuff to change. I wouldn't want Matt to change, I wouldn't want Ruby, and I wouldn't want Matt Ruby to change. I wouldn't want that to even fire. And that's what MobX is bringing to the table here. We're going to go through the core API. First, we need observables. These are what we can watch for changes. Computed values are kind of like full name, right? It's a combination, it's a derivation of your data. So first name and last name, that's a derivation of the first name and last name. Computeds are really powerful. Reactions are what do you want to have happen when things change. Transactions are how do you group changes as you're making them. Actions are a way to help organize your code. MobX has a strict mode you can make use of where if you only want people to be able to edit the data inside of actions, you can enable strict mode, and then MobX will fire an error anytime you try to edit a field on an object outside of a MobX action. And I'll demonstrate this later as well. Let's start with observables. So we have our person with the MobX observable. This is the only difference here. First name, last name, age. I'm logging out the first name. It'll show Matt. I'm changing the first name to Mike, logging it out. Changing the first name to Lissy, logging it out. The whole point of showing this is just to demonstrate how unobtrusive MobX is. Right? I didn't have to do get first name, right? Or set first name. It's just an object, right? We're not doing anything observable right now. I'm just showing the unobtrusive nature. Let's look at computeds. So in this example, again, we have first name, last name, age inside of MobX observable. And now we have a full name field. It's a function that takes no parameters, and it's going to return the concatenation of first name and last name. Right? Pretty straightforward. We're going to log that out, change the first name to Mike, log it out again, change the first name to Lissy, and then we're going to log it out again. Let's take a look. Matt, Mike, and Lissy, the 3 Ruby children are right here. Does anybody notice anything strange about this console log person.fullname there?
It's not returning the function.
Correct. There's no parentheses here on the end of the full name. It's not calling a function. Behind the scenes, MobX is using JavaScript getters. So it looks just like a field, but behind the scenes, it's going to run this function. We're going to revisit computeds in a little bit, and I'm going to show you how they can improve your performance tremendously by you doing no work other than creating them. Auto run. Let's actually start doing something with our observables. So again, we have a simple MobX observable, first name, last name, age. We have this new MobX auto run. What should happen with an auto run is it'll fire initially, so MobX will know what it wants to look at. And it's going to look at any calls within here and state, well, okay, I know this auto run needs to watch the first name and age fields and nothing more. So here I'm going to change my age 10 times to a random number. And then right here I'm going to change the last name 10 times to a random number. Let's take a look at the results. So we've got Matt and age. Let's take a look. We're just doing first name and age again. First name and age. This is the initial auto run hit where MobX is subscribing to everything that it needs to. And here's all the 10 subsequent hits. You'll see it didn't fire any changes for person.lastname. This is a trivial example, but this is one of the major things that MobX brings to the table. It's not watching last name. It's not firing a change on last name because it doesn't need to. Nobody's looking at last name. Nobody cares. Really, really powerful stuff. Let's take a look at a little bit more fine-grained option than auto run. We're going to look at reaction. Same observable as before. This time we're going to use a MobX reaction. A reaction takes 3 parameters. The last one's optional. First parameter is a function where everything in here is what's going to be watched. You can return the results of this function if you wish, and that will get passed down to your actual function that you want to fire on every change. And in this case, we're going to log out the first name and age and the last name. Note how I am not watching the last name above. Right? So this function is what's going to be watched. This is what's going to be run. And by default, reactions do not run initially. It will not fire this function on the first run, unlike auto run. So it's going to run this on the first run because MobX knows it needs to know what to keep track of, but it won't run this. So you'll see that it's going to change my age 10 times, change my last name 10 times. That shouldn't fire for that last name because it's not in there. And you can see it's printing it out 10 times. Really cool. Let's take another look at computeds. So in this example, again, it's the same as the previous computed example where we have the full name, except in this example, I've added a console log to show how many times we've hit the full name computed function. So the auto run is showing full name and age. So it's going to be tracking first name, last name, and age. So pretty much everything we've got is going to be tracked, right? In the auto run, we're going to print the full name and the age. 10 times I'm going to change the age. Then I'm going to change the first name to Mike, and then the first name to Lissy. Let's see what happens. So we hit full name initially, so that's how we get the Matt Ruby. Notice how all 11 times here we've skipped hitting full name because MobX knows that the first name and the last name have not changed. I've just changed the age. It has cached the value of that full name computed function for you automatically. I could hit this 1,000,000 times and it's going to return the cached value. This is one of the ways MobX will improve your performance tremendously. Here you can see I have changed the first name to Mike, so we've hit it. Here I've changed the first name to Lissy, so again we've hit it. So MobX is smart enough to track all these changes at all the different levels. Really, really powerful stuff. Let's look at transactions quickly here. Got to shrink this a bit. So we've got the same observable object we had before. We've got an auto run that's looking at full name and age. This time I'm going to change the age 10 times within a transaction. Next, I'm going to alter the first name and last name separately. And then I'm going to do another example where I edit first name and last name, again, within a transaction. Let's see what's going to happen. Here's the initial auto run. Here's where I changed the age 10 times within the transaction. Only fired once. Here's where I changed the first name to Mike. Here's where I changed the last name to Jorgensen. And here's where I changed the first name and last name inside the transaction. So it only fired once. Let's take a look at actions. Okay, so in this example, we have our same MobX observable, except this time I'm adding an action to the object using an assign. Set first and last name. So I have a MobX action where I'm using, in this case, I'm using a named anonymous function, just giving it a name. It takes first name and last name, and it's going to set the first name and last name. MobX actions automatically will run your code in a transaction. So most of the time, you should be using MobX actions, pretty much all of the time. Transactions can be nested within each other, so there is still some use for transactions, but 9 times out of 10, you should be using MobX.action. I have this same auto run as before, full name and age. Here I'm setting first and last name, John Smith, and here I'm still showing you how you can do it separate. I'm not running MobX in strict mode so that I can fire these guys willy-nilly. changing the first name to Mike, last name to Peterson. We should see one call for John Smith, and then two calls, one for Mike, one for Peterson down here. So let's see what happens. So we've got the initial, Matt Ruby. Boom, one line for John Smith, so we can see it's running transactional. Then we have the Mike, and then Peterson. Everything's running as we expected. There's other functions available to you, most of which you won't need very often. Extend observable I use very frequently. Other than extend observable, I haven't needed to use hardly any of these other functions. And when you need them, you'll go looking for them, and they're there for you. Just so you guys don't feel left out, not that many people online are using MobX with ES5 the way I'm showing it to you today. Most people are using Babel or TypeScript with decorators enabled. Again, you don't have to do this. I don't do this. Many people don't, but it is available to you, and many examples are written this way, so I just want to make you aware. You can have your ES6 class. These are decorators. I still think of them as annotations from the Java world, but they're decorators. And right here, you're marking the title as observable. The ID here is not observable. The finished flag, this Boolean, is observable. Here's a computed. I'm not going to go in depth in this. I just wanted to show you guys, the ES6 folks out there, that these are all available to you. Let's start digging into an actual example. So I know you guys are accustomed to to-do lists because that's what everybody does, but I work for a furniture retailer. We're building a swatch list. So let's figure out how we want to go about doing this today. Step one, I'm going to go through a non-MobX example of this React application. Just a totally normal React application being rendered from way up on high. It's going to be stateless. We're going to spend a little bit of time converting this over to a high-level MobX reaction. And I'll show you kind of how you can take your existing application yourself and convert it over to MobX. Next, we're going to actually build it how it should be done using a MobX React observer. I don't know if we're really going to have time to go through stateless functions or not. It's just kind of gravy anyhow. We will definitely be discussing the performance implications of using MobX and how easy it makes some of these really, what used to be really difficult and putsy work, very, very simple. So with that, let's take a look at our example application. So here we have our swatch list. And as we change swatches, you'll see pretty simple application. Let's take a look at the DOM and see if the virtual DOM is kind of acting as we'd expect. So you should be seeing these changes, right? The virtual DOM's only changing what changed. React is doing exactly what it should, when it should. It's great. Let's take a look at the React Dev Tools real quick. I want to show you guys how this is all props driven. We are going to look at the code in a second. So you can see it's all props driven. There's no state. Very simple application, right? The selected state is changing from true to false based on what I click, and the selected swatch is updating accordingly. Let's actually take a look at the code. Let's start at the top with our index file. So here, we're initializing a store and handing it some swatch data. We'll take a look at that in just a second. On the store, I have, in this particular case, there's only one action, but I have a collection of actions. One of them is called swatch data changed. I'm adding a callback, so whenever swatch data changed fires, it's going to fire this callback. This callback happens to be a React render. I'm handing the store down to the viewer full render component. And we'll go look at that after we take a quick look at the store. So here is our swatch store. Takes the JSON data, assigns that data to itself. We have these listenable actions. This whole memorize thing is just so it will fire initially. I have two functions. One getSelectedSwatch, where it's just going to find the selected swatch. Another one where we set the selected swatch. First, we take the currently selected swatch, set its selected state to false. Next, based on material ID, we go through the swatches, find the next swatch to select. Pretty simple. Then we dispatch that action to state, it changed, go re-render, right? So now you've kind of got that loop. Let's take a look at the viewer code. Just very simple. We're creating a React class. We're unpacking the selected swatch from our store. Here's the H1 fabric details, store title. Here's where we're rendering the selected swatch, so this image and this text. The swatch group renderer is going to render the collection of these swatch thumbnails. That takes the array of swatches and the callback function. I'm doing the bind right here, where I'm binding set selected swatch to the store. Here's the callback. The selected swatch renderer, again, is very simple. We're just taking the selected swatch, rendering the image and its name. Here's the collection of swatches, the swatch group renderer. We're mapping all these swatches. We're going to create a swatch thumbnail renderer. Swatch thumbnail renderer takes the swatch and that callback function from before. The key is just for React to properly render arrays. And we're just pumping that into the swatch container. And then here's the individual thumbnails. Very simple. The only thing that changes is based on whether the swatch is selected or not. We'll set a selected class name, right? Is it selected or not? Swatch click handler, I'm going to log out the swatch ID that was just clicked and call the set selected swatch function, right? Very, very straightforward, standard, top-down, props-driven, stateless React application, right? Everything, we're just rolling on props. There's no state, no funny business whatsoever. How would we go about converting this over to a MobX application? I would typically start at the store. So let's use MobX.extend observable. Save it up. Refresh, and now our store is observable. Don't believe me? I don't blame you. We're not doing anything with it whatsoever. We are doing nothing with it. Let me grab a snippet here. I'm going to add an auto run where we're going to look at the store swatches, find the selected swatch, and just spit it out. So now we are actually going to observe our store. I'm going to prove to you that MobX is running in the background. The auto run initially fired, and there's our selected swatch. If we go take a look at the name, Tatum Mink. Now, have you guys noticed these dots here? What's going on there? That's using the JavaScript getters behind the scenes. These fields are really neither here nor there because nobody's asked for them yet, right? This is one of the other ways your performance is improved, especially with those computed fields. If you don't hit the field, MobX won't run that function at all. So let's click around. Anybody else notice this undefined here? That's kind of strange. Let's try to figure out what's going on. So we've got the undefined. Let's click over here. Okay, we're getting it right here. That makes sense, right? So let's click that again. It should break. Now, I'm using the black box feature in Chrome DevTools. I don't know if you guys know about this, where you can right-click, black box a script. I've already black boxed React and MobX. So I'm not seeing any garbage in my console whatsoever. I'm just seeing my code. Really, really useful feature. MobX is completely synchronous. There's nothing async going on behind the scenes. This is the actual stack. Even though that MobX, I set a breakpoint within the MobX auto run. There's no funny business in there. It's all synchronous. This is the stack. I could do a console.trace anywhere, and see who caused what. This makes debugging very, very easy, as I'm showing you right now. Does anybody know what the problem is? Based on looking at this, can anybody tell me what's wrong?
Because the function is anonymous?
No, it's because I'm not using a transaction. I am deselecting the selected swatch, which has changed the swatches, which MobX is watching, so it's going to fire. Then I go select the swatch, which is then why the second hit works. So let's quickly convert this over to a MobX action. The first optional parameter with a MobX action can be a string. And this is helpful for debugging, and I'll show you that in the React example later, just how valuable that can be. So now, if we don't need that, we can cut it loose. And if we do F5, we run the auto run again, right? Now you'll see it works, because now it's running within a transaction. Actions automatically give you transactions. Really cool, right? Let's keep converting. So the next thing I would do is this whole getSelectedSwatch, I would change that over to be a computed function, right? Why wouldn't I want this to be cached up if many people are asking for it and it never changes? So doing that is really simple. By the way, I don't know if any of you have noticed, we are still not using MobX on this application at all. It's still running using the actions. I haven't had to remove any of that stuff. I still don't. So we'll just keep extending in the extend observable. And we'll do selected swatch. And can't live with myself unless I format this a little bit. There we go. We have a computed function. So if I refresh this, I hit escape, and I do store.selected swatch. You can see Chrome DevTools is even auto-completing this. It knows it's a field. Here's my selected swatch, ready to go. Let's actually make use of the selected swatch. So let's take this. And we'll get rid of this, because we're no longer going to need it. So the first getSelectedSwatch we'll need to lose is this one. There we go. And then we'll also need to update our viewer and just replace this call to getSelectedSwatch. Change that to selectedSwatch. Now I just want to make a note here. This is the only change I'm going to make to this viewer code in this particular demo. This is it. Right? This was, as far as my React renderers are concerned, I just made a choice where instead of calling that function, I'm now just going to use this computed field. So if we look in the store, yep, so this is using selected swatch. So's the viewer. If we refresh, everything still works. Let's try doing a slightly crazier auto run here. So I mentioned how MobX is going to cache up these values. In this example, we're going to call the selected swatch 1,000 times every time it changes, right? Because it's in an auto run. Let's add a quick count here. Got to do that before the return, huh? Console.count. And we'll say selected swatch. Save this. Run this again. And execute that. Now this is still going to be getting hit twice because I'm still using the setter in a slightly weird way from the renderer. But bear with me. So we hit this. It was only hit 3 times. 4 times. 5 times, even though I'm hitting that field thousands of times. Right? This is really cool, powerful stuff. let's finish our conversion quick here. Let's get rid of our listenable actions entirely, because we're actually going to use MobX for the reaction now. There we go. No more actions. If we go to, we got to hit the index file. We're going to get rid of this. And we're going to replace this with a MobX.reaction. We only need one of those. That callback's ready to go. We just need another one. And in this function, we're just going to do store selected swatch. So now the reaction knows it needs to keep track of the selected swatch. Let's see what happens here. Nothing. Let's see, do we have any errors? No, no errors. This ran, because we're seeing this. Anybody remember what I told you guys earlier about reactions? They will not run initially unless you pass a Boolean of true as the last parameter. Now it will fire initially. And there you go. We now have a converted MobX application. This is a little bit of a naive implementation. We're not really leveraging all the power of MobX right now. And I'm going to show you that in a second. But we're using some of it, and that's better than nothing. Pretty neat. All right, let's move on to, let me toggle presentation mode. Let's move on to a more interesting, a more MobX example. So in this example, I have a new store. Let's take a look at this. So this is just a slightly more detailed implementation of my observable swatch store. So we're doing an extend observable. We're setting the title. Swatches I'm mapping over to its own observable. So normally it would just observe everything about swatches. I don't want to do that. The only thing I care to watch on swatches is that selected Boolean. That's it. Selected swatch is the same as it was before, and set selected swatch, I'm using the MobX action again. The only difference here, is I'm doing my bind right here. So I'm binding it right here, just saving myself a little time in the React code. Let's go back to the index file. Control E. Now you'll see there's no event tracking here. So a lot of you are probably assuming that viewer full renderer has been converted over to a smart component, right? Where it's stateful, right? Where I'm doing something where, oh, this guy has an auto run and he's automatically watching the store and all that kind of stuff. That's not the case at all. So, viewer full renderer. The only change I have made to these React components is I have wrapped all of my components in MobX React observer calls. Right? So each and every one of these guys is the same as it was before. The only change I made is this. What the MobX observer is doing at a kind of a crazy high level is it's wrapping each one of these guys in auto runs. Notice there's no state. There's no state. It's all still prop driven. Everything's kind of wrapped in its own auto run, and MobX has its own pure render function where it's gonna shallow check your content as well. So again, it's all the same code. This is a fully MobX'd out app at this point. Let's go back to that index file, and we're going to run it in Chrome. Here we are, example 3, and it's working. Let's take a look at the dev tools. Everything seems to be working. Pretty slick, right? Nice and easy. If we take a look at something, I'd like to show you guys something kind of neat. I'm going to turn on trace React updates here. So you'll see there's these blue outlines that are going to show up now. Every one of those outlines represents a call to React Render. There's nothing wrong with having lots of React Render calls with most applications, but when you start getting into things like animation and drag and drop, you don't want all your children to be rendering all the time. Let's go back to the first example and let's enable that same feature, Trace React Updates. You'll see all the swatches render functions are being called. Now, again, that's perfectly fine. This is what React is meant to do. It's going to take all those renders, compare them against the virtual DOM, and only apply the changes to the DOM that actually matter, right? This is totally normal. It's okay, especially in a trivial example like this. But have you guys already noticed the difference? Every single one of these swatches renders every single time, as opposed to over here you'll see only the swatches that change. The render calls are being made there, only there, for like no work whatsoever. So let's turn that off for a second on both. And let's go back to example one's code. And I'm going to enable this interesting project called Why Did You Update? This is going to make my console go crazy. And let's get rid of the console count because it's going to be crazy enough. I'm going to refresh. What Why Did You Update does is it's going to log to the console every single render that did not need to happen. So what this plugin's doing is it's showing you all the places you could use should component update to improve your performance. Now again, most of the time you don't need to worry about this, but sometimes you do. Right? So let's look at our third example again, and let's go look at the code. I have had Why Did You Update running the entire time on the third example. What that's telling us is that MobX is running the bare minimum number of renders to spit out the changes, right? It is completely optimized. And again, we got that for almost no work. Let's take a quick look at the MobX dev tools. So I'm going to turn this off on example 3 because the MobX dev tools are not quite as optimal as that Swatchland code. So let's turn this on. Go back to the web browser looking at example 3. Let's hit refresh. Let's give ourselves a little bit more space. And let's turn on this kind of profiling tool that's going to show us, it's going to visualize the changes and how long they took. So don't blink, but 2 milliseconds, 4 milliseconds, no milliseconds. Right, so this is kind of handy to give you that same visualization. It's showing you the actual changes. This tool will allow you to see what your components are dependent upon. So the render function of the swatch thumbnail renderer is looking at only the selected, right? Really cool. Let's take a look at the collection. This one is only dependent on swatches. This is really cool stuff. This allows you to very easily debug your application. Now, if that's not easy enough, let's turn on kind of the MobX advanced debugging here. And this is part of the React Dev tools for MobX. When I click on a swatch, it's showing me the action name and all the reactions that occurred based on that. How easy is that for debugging? Right? Your lives have just gotten so much easier thanks to this one feature. Let's take a look at the action. I can see it's showing me the parameter that was passed. This is the new swatch ID. It's showing me this is the transaction. It's showing me the 2 updates. The new value is false, the old value is true. And then We don't need to look at the stack at this moment. The stack's available to you, and you can see the other swatch has changed. You can see what field was changed, who changed the field, where they changed it, and then all of the reactions because of it. Not to mention how long it took. This is really, really cool, powerful stuff. Now, I could leave you right here, and you could go off and you could build your MobX applications. Keep going. I'm going to just talk to myself. I'm not going to stop here. I'm going to show you something where the performance could be impacted. So in this example, let's just run it. So we're going to go through all this in the browser. In this example, we have the ability to animate. We can toggle that off and add swatches. So let's clean that up. Let's turn on the DevTools. And I don't really need to see that. Let's go to React. Let's trace our React updates. So when I toggle the animation, you'll see none of the child swatches are being rendered at all. Right? Let's turn that off. Let's add some swatches. Let's add lots of swatches. Okay, so we've got a couple thousand swatches here. Again, when I toggle my animation, you'll see it's not doing any of that, and I can still change my swatches, no problem, and MobX is smart enough to know only those particular swatches need to change. I have not had to write a single should component update in this example. It just works. Right? This is really powerful, cool stuff. Let's go back to the presentation. If you have any questions, please feel free to ask. You can find me out on GitHub under Matt Ruby. Please feel free to take a look at my MobX examples. Nice, simple ES5 examples, one at a time. And this entire demo is available to you as well. Thank you for joining me.